Most of you guys think you know how to do something as simple as read these instruments that you're going to be using. Like we've already had to read this one, graduated cylinder. I told you to pour out 10 milliliters of salt water or whatever, and you just read it. You just figured I know how to do that. It's easy enough. I just 60 or 70, I could do that. And you're going to have to learn how to read more complicated things like this balance, all right? And you know, that may be a little bit tougher, you think, but it's not that bad. I've seen I got my weight done in the nurse's office. They have the same kind of scale there. But you'd probably be wrong. In most of the stuff you wrote down in the homework, if you tried it tonight, ahead of time, you probably are wrong. And let me show you why. There's something called significant figures. Reading these instruments is not as easy as you think. Right? It's not like math class. Numbers aren't infinite in our world. In science, they're limited by something I just talked about a minute ago, the precision of the instrument. Okay, how far? Like for example, when I read a ruler, I'm going to use this ruler in a second up here. How would you read? I can certainly read a ruler. All right, everybody, you've been reading a ruler since you were in kindergarten. Probably been using a ruler. All right, let's see how well you do. Okay. So these are significant figures. What I'm going to read in the notes. There's not going to be a whole lot of notes here. It's going to be mostly me explaining stuff. And then I'll let you practice this and see how well you do. We'll have a little lab on it tomorrow, mini lab and a worksheet, and do a little bit more with it. All right, because it's going to be one of the most difficult concepts you're going to actually see this early in the year. Very difficult for you guys to get used to doing. Okay, I'll explain. Let me show you with this ruler here. Okay? Okay, rid of that. Now this ruler is pointing at measuring, three different things. Let's just say I was measuring a piece of paper with the ruler, and the first thing I measured, it came up to here. It was that big. That's how long it was. All right. I was measuring something there, measuring something that was that long, and I was measuring something that was that long. Okay? If this is where it ended, what is that? Assuming that, by the way, that this is in centimeters. Okay? That's where it ended. Listen, what would you say the length of that piece of paper was? 12 centimeters. Okay. And I'm glad she said 12 centimeters. So a lot of times I get people who just say 12. All right? You have to have a unit. Get used to that in chemistry, too. Got to have a unit next to every number. Centimeters, meters, millimeters, whatever. Okay. What about this guy right here? What do you think he would be? Austin. Okay, I'm glad he said something else that is nice. He said 12.5 centimeters. He didn't say, I bet a lot of you, if I called on you, would have said 12 and a half. I get that all the time. 12 and a half. All right? We cannot use half and third and three-quarters and that kind of stuff. You do that when you're measuring, we're cutting lumber and stuff like that. Those of you who have helped out around the house, maybe if you're measuring stuff or, you can't do that here. We have to be very precise. We cannot use half. All right, half implies an infinite number of significant figures. All right, 0.5 tells me exactly how many I have. All right, let's go to the last one. Now, this one, and I call it something up front because you can probably barely see it. It's not quite on one of those lines. So, Jacob, what do you think that guy probably is?
12.9 centimeters.
Is it right on a 9?
No.
So, what might you say? 12.9? 9.5. Again, can I use half?
12.95.
Okay, he says 12.95. All right, that's what he said. All right. Now, my question to you is, which of those do you think is most likely a wrong answer? Which one do you think is the least likely to be correct? Yeah, most people would pick that one. And that's the only one that's right. The other two are wrong. They're completely and utterly wrong, and they will get you no points in the test. They will absolutely, on this test, get you no points. Because in this test, I'm purposely teaching you about significant figures. As I told you. That's why you thought I was kidding about 75 and 78 having to redo them. You will have to redo them all. All right? Because you did not read them correctly. That's wrong, and that's wrong. because of significant figures. Because you did not read this instrument correctly. What's the correct answer for this guy, do you think? Right here. Anybody take a guess at it? 12.00. Oh, I think I have it actually written down here. 12.00 is the correct answer. And the correct answer for this guy? 12.50. And that guy? Well, Dave said 12.95. If you look at it close, I pick up something close. It's actually a little bit less than halfway. So I would say like maybe 12.93, maybe 94. Okay. Now, why is this correct, but the other answers were wrong? Here's why. When you give me an answer, you've got to tell me in your answer what the precision of the instrument was. You can't make up or lose. Here, the law of conservation of matter and energy, think of it that way. Can't create or destroy matter, or can't create or destroy significant figures either. All right? I have to have the correct number that was used for that instrument. This instrument can be used to measure. We all agree that that's a correct answer. You all agree that I can make, and by the way, if you're wondering about that 3, that's the number I wasn't so sure about. Why do I put it down there if I'm not sure about it? Because it's still important. For example, can you all see this? I know it's not huge, but I hope you all can see this. If we can clearly see that this H is not 12.99. It's not that far over. It's not 12.96. It's not even halfway if you look carefully. It's a little bit less than half. So I know it's not even 12.96. I also know it's not right. It's not 12.91. I'm not sure if it's 12.93. It might be 12.94 or 92, but it's definitely not 99. So this number has significance. It's just not exact. All right? Would it have made sense if you said this for your answer? For this answer here, 12.93147. Would that have made sense? Is that a better answer even? No, because these numbers over here, where'd you get them from? Do you have any reason to say these numbers over here? No. You have a very good reason to say that guy. You're positive about these 3 guys, aren't you? Isn't everybody positive that it's 12.9 something, right? When it falls right there, you're positive of those. But you have to estimate that last one. And that's what you do in significant figures. You estimate one place beyond the smallest division on the instrument. This is going to take some getting used to. And I will illustrate this as we go along. All right? Significant figures are all the digits of a measurement that are known with certainty. You're sure about the 12.9 plus one uncertain digit that you're estimating. And that's how you got to get used to reading scales around here. Any kind of scale. Okay? I'm going to show you a lot of different scales today. Basically, anytime you use this ruler, you have to have the same number of decimal places whenever you use it. So, let me ask you something like this. See if you can just use it before I go on to something else. What if this guy landed right there, right on this line right there? What would you call him then? Everybody get an answer in your head. You're not going to learn anything if you're just going to wait for someone else to answer. What would it be if it fell right on that line right there? What would the correct answer be? Mike?
13.40.
13.40. Correct. What if it fell right on this line right here? Right on 14. What would you call it? Zach? 14.00. Good. Every single time you're going to have that many decimals. Now, here's what people heard. That's what I said. Here's what people heard. Okay, so whenever I use any instrument, I'm going to put 0.00, or I'm going to put 2 decimal places after it. That's not correct. Let's see what happens if I have other instruments. Okay, there's something else that might happen here, something that's different. Because the reason you're doing that is very simple. Something that I explained with this 3 there. I am certain of these numbers. I'm not certain of that one. I can estimate one place beyond the smallest division. And that's what you're going to do in every instrument. You're going to estimate one place beyond the smallest division on the instrument. That's the easy way to do these. Now, you don't have to draw this ruler because I have the exact same ruler on a worksheet, which, by the way, I just went to get my copies and they aren't there. I'm going to see if I can, while you're working on the homework, fixing those problems, I'm going to see if I can get still over in the copy room. Because they weren't up at the office. Because I want you to see that. You won't take you the whole period to finish that. All right? So you have to estimate one place beyond. What's the smallest division on this instrument? What's the smallest division mean? These are ones. 11, 12, 13, 14, correct? What would these guys be then? Tenths, right? These are tenths. Everybody see how you read that? 12.1, 12.2, 12.3, correct? Now, so the smallest division on the instrument in this case is tenths, okay? So you have to go one place beyond that, to the hundredths. That will always work. One place beyond the smallest division. Time to practice this. You ready? All right. Let's look at these guys. Again, you need to think, and you need to answer these in your head while I'm doing them. They're not going to be necessarily what you think. And if you're making mistakes, make them now. Look at that guy right there. First one. What do you think he is? How would I measure? What would I write down on my paper for that measurement? Raise your hand if you think you know. Raise your hand. What do you think, Kyle?
4.50.
No. And that's exactly what I said would happen. Are you going to put two decimal places after everything? What's the smallest division on this instrument? Ones, not tenths. Ones. So where do I have to go to? One place beyond that, which would be the tenths. This guy is 4.5. See it? How many were thinking 4.5? Raise your hand. Okay, most of you. Good. Let's look at this guy. And again, it's hard to see. I have this on my, it's a big class, a lot more people sitting in the back. This guy falls just short of that line. Just short of this line right here. Okay? Get an answer in your head, what you think he's going to be. How would I read that scale? Raise your hand. What do you think? Gavin? 4.58 would be fine. 4.56, 4.57, 4.58, I would accept. All three of those. Okay? What I would not accept is 4.5. So it would not, I want to make this clear too, by the way. Say, for example, you thought this didn't quite make it halfway, and you said that 4.4. Am I going to mark that wrong? No. Am I going to mark 4.57 or 4.58 or 4.56 wrong? No. They're all, that's an estimation. You can estimate differently than I see it. That's okay. What would be wrong is calling that 4.5. That would be wrong. Or 4.6. That would be wrong. Because of the decimal places, because of the precision, because of the significant figures on the instrument. There are tenths on this instrument. This is ones. These are tenths. So I have to go to the hundreds. And that's why the correct answer is 4.56. Try this last one. Oh, I gave it the answer. Sorry. Didn't mean to hit that. You see why it's 3.0? That was bad because I really wanted you to get that wrong. I know it seems cruel, but I do want you to get them wrong now because it's better to get them wrong now than to get them wrong on a test. A lot of people would have put down 3 for that, right? And you see why you would have put down 3. Because it's right on the 3. Well, what's the smallest division on the instrument? Ones. So you got to go to the 10th. So if it falls right on it, that 0 is saying, I could have estimated that. I did estimate that. I think it fell right on it. Okay? For example, what if it had fallen, what if this guy here, what if it had fallen right on this 4, right there? What would you have called him? You would have called him 4.00. You see? What would you have called it fell right on this 2? 2.0, not 2.00. Again, there's 2 ways I tell people to try to learn how to do this. Okay, here's one way. Figure out what the smallest division is. Smallest divisions are ones. Smallest division, tenths. Smallest division, ones. Go one place beyond that. That's one way you can do it. Here's another way. Assume the number. You don't get it right if it falls in between. So I'm sorry, you don't get it wrong when it falls in between. So say this guy fell right here. no one would have gotten that wrong. The only thing you would have probably put for that, if that had been that long, is 3.5. Now, if you had 3.4, 3.6, I don't care, but 3.5. If you could have 3.5 for that guy, this guy's got to be 3.0. Same number of decimal places every time. All right, let's try some more. Rulers are easy. How about graduated cylinders? There's something I need to tell you about a graduated cylinder right now. I used to use a camera and project it up here, but you guys have seen this before. Have you noticed that when you're looking at turn that light on for me in the front here. When you're looking at water inside of these, there's often a curved surface. Anybody know what that's called? It's called the meniscus. This curved surface here. All right, turn the light off again. You have to learn where to read that from, because there's a big difference depending on what it's in. Look at here. Here, the difference is an entire line and a half, right? From here to here. Where do I read it from? Okay, here it's even more than one line. The bottom of the meniscus is down here, and the top is up to here. So that's 1, 2, 3 lines difference. So that's a big difference in your answer. If you're reading from the top of the meniscus, you're reading wrong. Okay, you're reading the wrong value. You read from the bottom of this curved line. You read it from the lowest point on that curved line. The reason there is a meniscus, by the way, is the same reason we can pour down a stirring rod. What did I say when we pour down a stirring rod happens? What does the glass do? It attracts the water, right? Well, this glass is attracting the water, and it's kind of climbing up there. It's also the reason for capillary action, right? We'll talk about that later, too. All right. Can you read this value? Assuming that this is a 6, I kind of have to write some stuff in here. All right. If this were a 7, and this is a 6, okay, what would you call that? Everybody get an answer. What would you call that? First of all, you're reading from the lowest point, which would be right there. All right. What is that reading? Savannah. 6.31. Okay. This is 6.1, 6.2, 6.3, 6.4. It's a little bit above that 6.31.
What's the formula for percent error? Accepted minus observed over accepted. What's the formula for percent error?
You just did it! Yes.
Okay.
Times 100.
Times 100. Okay.
All right. Yeah, I told you you'd be doing it in physics class. So, 6.31, you all agree? Does everybody go with that? All right. What if it fell right here, right on that line right there? What would we call it there? 6.50. You go with that? All right. How about this guy over here? This is a 50. That's a 60. You see where he falls? Somebody give me an answer for that one. Raise your hand. I really hope I get some mistakes on these, because when you get mistakes, you see what people are doing wrong, and that way you won't do them again. Sometimes you kind of go along and you don't realize it. What do you think, Zach? 52.9, he says. Let's see. Do I have the thing in here? Yes. All right. Well, here's 50, and there's 60. So 51, 52 point, I would say maybe 52.7, but whatever. I wouldn't take off for 52.9. All right, because it's a little bit lower than that. All right, where that line is. All right? Okay? You know what I get people to do on this one? I was hoping it would happen. You just got done calling this guy 6.1, 6.2, 6.31. I was hoping, and I bet you someone was thinking this, 50.29. Right? Now, what do they do wrong in that one? That is not a significant figure mistake. You know what that is? That's a scale mistake. If this is 50, and this is 60, this cannot be 50.1, 0.2, 0.3, 0.4, 0.5. This has got to be the division between 50 and 60. What do each of those have to mean? They have to mean what? Ones. You see? If that's a 50. Now, if this were a 5 and that were a 6, what would each of those divisions be? Tenths. You see what I'm saying? So that's, and I know people were thinking that. We're going to put down 50.29. I'll bet you money. That's why this is going to take so much practice. It's why the first one I'm going to give you, I'm going to let you work with your partners in the back of the lab tomorrow on that worksheet with other stuff. I'm doing that for a reason, so that you can work together and get used to doing it. Not easy. All right, let's do some more. Read that guy right there. I don't know if you can see him really well. Turn the light off, you can see it a little better probably. Yeah, that's a little better. It's right about halfway between this line and that line there. Okay, what do you think that is? See, it gets tough as we start to get different values for these. Look at what, this is 900. That's 1,000. What must each of those be? Think. And then if it falls between them, what would I call that? Raise your hand. What do you think? Who has an answer? Come on, somebody else. Gotta learn some people's names here, man. Taylor, what do you think?
920.5.
Okay, close. She's got the scale right this time. Put the light back on so I can see a little better. She's got the scale right. I guess you can't see it long. You better leave it off. Yeah, she's got the scale right. It's 910, 920, 930. It falls between the 920 and the 930. It falls halfway between 920 and 930. So what is the next place to estimate here? If these, what are each of those lines? Tens. So what do I estimate to? The ones. So 925 is the correct answer, not 920.5. 920.5 you couldn't tell from this one. You'd be going one extra space. All right? The next place you're estimating is to the ones in this. That's your estimated value, isn't it? Isn't that one you're not sure about? That's the guy you're not sure about. Is it 9? Here, this is 920. This is 930. It falls between 920 and 930. I think it's about 925, but it could be 924. It could be 926. I don't know for sure. So this is the 5 that's estimated. To call it 920.5, that would be right there, right above that line. That's not correct. And plus, you couldn't do it because you'd be estimating 2 places beyond the smallest division. Not easy stuff, as you're finding out. Let's do another one. Put the light. I think this is easier to see. The scale. The scales here. I just took a picture of my phone of these. Okay. Again, I used to use the camera to show this, but you're going to use these scales tomorrow as well. Okay. How do you measure these? Well, basically, when you use these, I guess I can show you real quickly. You can see this on the camera. Yeah. When you go put something on a scale here, whatever you put on it, I'll put my little pen on there. It makes it, makes this side go down. Okay, so this side's too heavy. So what you do is you want to move each of these guys until it balances. All right? That's not staying on the scale very well. Let me put them a little bit heavier there. My calculator. All right. If I move the heaviest one first, all right, and I have to make sure it's clicked in place, I notice that's too heavy. Okay? So I move him back to where he was. Next heaviest one, I move until it becomes too heavy. So I slide this guy over until he becomes too heavy. And it's very important you actually lock these guys in place. If you just go between two, you have no idea what you're looking at. So I have to make sure it's locked. That's too heavy, so I go back one, and there you have it. Okay? Well, now, it's still not quite balanced. I want it to be balanced. This little line here has to be balanced with that line there. All right? So I go to the next one, and I'm sorry. It's still too heavy. Sorry. The back one. So I move this guy up one at a time until I finally get him to be too heavy, and then I go back one. Still not. Still not. There. Too heavy, I go back one. And now I slide this last guy around until I get him to be exactly balanced over here. All right? So, that's how you use a scale. And I think most of you have seen the nurse do this when you're getting your weight taken, all right, for your things. Okay? All right, so that's how you would use this. I think most people could use this. But could you read it correctly? Take a look at what's up there. That's what you might see when you're all done. Something that looks like this. How would you read that? And again, I will show you with a line here. This guy is pointing basically right on that line there. That's where he's pointing. So what do you think this guy is going to be read as? Yeah, raise your hand. Everybody get an answer. What do you think? Josh.
145.57.
145.57. Nope, but close. What's wrong with it? What do you think? Kyle.
145.57.0.
Okay. 145.570 would be correct. Do you see why? Two ways. Let's look at it two ways. One, what's the smallest division on this instrument? These are clearly what? Each of these are what? Tenths. Which means these guys are hundreds. So you got to go one place beyond that to the thousands. That's why you need that zero there. Okay? And here's the second one I told you. What if he fell between these two lines? Between those two lines. Wouldn't you have called it 145.625, right? If you could do that there, if you call 0.625 there, and you have that, you have to have it here if it falls right on a line. Okay, you got to have it. These are tough. You're realizing now why you're going to have to redo these, I'm sure. All right, because you probably didn't do any of that when you were looking at this a minute ago. Okay, let's do one more. It's the last one, I think. Check this one out. See if you get it right. Turn the light off. Let's see if it's any better with it off. Yeah, it is, definitely. Leave it off for this one. Okay, raise thy hand. What dost thou think? Margaret. Ah, very nice. 145.600. Same scale. Same hundredths being the smallest. Got to go to the thousands. It happened to fall right on this guy. So it says it's clearly 145.6. How many zeros do I need? In this case, 2, because I got to go to the thousands place. Now, of course, what happens in these? Keep the light back on. Here's what happens. People just randomly throw zeros after everything. All right? Or maybe I need an extra zero here. And they have no idea why. But I'm telling you why. This is the deal, guys. It's very simple. You look at your scale. Everyone knows how. See, I don't know why this is so hard for some people, but it will be. This chapter is always brutal for some people. It's very simple. Anyone, if I ask these questions, can give me the correct answers. What's the smallest? What do these little lines mean? I rarely get a wrong answer to that. Most people can see that that's 0.5 and that's 0.6, so these are tenths. So that must be hundredths. So you answer that question correctly. Then I ask you, okay, apply the rule. You estimate one place beyond the smallest division. You got to go to the thousands. If you're already at the hundreds, you got to go to the thousands. And if we look back at the other ones, they should seem easier now. Oops, sorry. They should seem a little bit easier now. Smallest division, ones. What should this answer have? Tenths. Smallest division here. Tenths. What should they be? Hundreds. Smallest division here. Ones. What should you have to estimate to? Tenths. See, that's what you have to do. You have to apply that. The problem is you're applying it with graduated cylinders and a meniscus. You're applying it with a ruler. You're applying it with a thermometer. You're applying it with balance. There's a whole bunch of instruments we're going to use all year long that you have to apply that to. All right. Redo if you already tried it. 75, 78. And I will look for